What's up guys, welcome back to another video here at Achieve Academy, and today we'll be going through fractional and negative indices. Please like and subscribe if you haven't already, because I promise you it is this easy. Our learning outcomes for today is to understand what fractional and negative indices are and what are the rules we need to know when we're dealing with them. It's also to solve fractional and negative indices exam questions. So, before we look at fractional and negative indices, what are indices? An index, or a power, is a small floating number that goes next to a number or letter. The plural of index is indices, and indices show how many times a number or letter has been multiplied by itself. In this lesson, we will focus on solving fractional and negative indices exam questions and understand the rules of multiple indices. So, we already know the basics of indices and reciprocals, such as a third is a reciprocal of 3, but many of you may not know it can also be written as 3 to the power of minus 1. If the number has a negative power, it simply means it can be written as a fraction. And if the number is bigger than 1, we use our power rules. So 3 to the power of minus 2 would be 1 over 9. Because you have 3 to the power of minus 1, which is a third, and then you square that. So you're doing a third times a third, so you get a ninth. If we have fractions that are to a negative power, we flip the fraction. So 2 thirds to the power of minus 1 would be 3 over 2. If this was 2. Once again, it's that time to have a go at some Maths Genie exam questions. Have a go, pause the video, and unpause when you've done. So, with our first question, we're asked to find the value of 3 to the power of negative 1, which is simply a third. Second question, we're asked to find the value of 4 over 5 to the power of minus 1, so this is simply 5 over 4. Find the value of 5 to minus 1 is a fifth, and find the reciprocal of 3 is a third. These are just some questions to warm your brain up, so you're going to get used to when we're dealing with negative 2s or negative 3s. With fractional indices, we have an order in which we must use. For example, to solve 8 to the power of 2 over 3, we would first cube root 8, which would give us 2, then we would square 2 to get 4. And like we did before, with fractions, we simply flip it if it's a negative power. But we only flip at the end after we've done our indices. You will also be asked to solve for a power, usually given as n. With these, use your knowledge of substitutions into equations and write the number with common powers, such as, in this example, 4n equals 8. 4 and 8 can be written as powers of 2's. So do 2 squared, brackets n, equals 2 to the power of 3. Now, our 2's cross cancel as we've got the same base here. So we do our 2 times n, and this would equal 3. So 2n would equal 3 in this scenario. Here are some more exam questions for you to have a go at. Have a go, pause the video, and unpause when you've done. So, with our first question, we're asked to find the value of 64 to the power of negative 2 over 3. First, we cube root 64 to get 4, and this would be the power of negative 2. That's also the same as writing 16 to the power of negative 1. So our final answer is a 16th. Second question, find the value of 125 to the power of 2 over 3. Cube root 125, so we get 5, and then it's just squared. So our final answer would be 25. Third question, find the value of 8 to the power of negative 2 over 3. Cube root 8, we get 2, and this is to the power of minus 2, so this is 4 to the power of negative 1. So it's simply a quarter. Find the value of 27 to the power of negative 2 over 3. Cube root 27 to get 3 to the power of negative 2. So this is 9 to the power of negative 1, which is a ninth. Then our final question, find the value of 8x to the power of 6 in a bracket to the power of 2 over 3. Now, here we still use our power rules and cube root the whole thing first. So we get 2x, which is squared, in the bracket, which is squared. You may have remembered, as we have a 6 inside the bracket, and then powers outside the bracket, we use our laws of indices. So we do 6 divided by 3 in this instance. And now we simply square the bracket. So our final answer would be 4x to the power of 4. Now, here are some of the hardest questions you'll probably be asked on fractional and negative indices. Have a go, pause the video, and unpause when you've done. So, given that 3 to the power of negative n equals 0.2, find the value of 3 to the power of n bracket squared. So, if 3 to the power of negative n equals 0.2, which can also be written as a fifth, that means 3 to the power of n equals 5. As we were on about before, it's 3 to the power of negative 1, this would equal a third. So 3 to the power of n would just be 3. So 3 to the power of n bracket squared means 5 squared, which is 25, so our final answer is 25. Now, with our second question, given that 5 to the power of negative n equals 0.5, find the value of 5n bracket cubed. So we use the same method as we did before. 5 to the power of negative n equals a half, meaning 5 to the power of n equals 2. So we cube 2 to get our final answer of 8. Now, with our third question, given that 4 to the power of n equals 8, find the value of n. Some of you may remember, but this is a question I used as an example before, so you already should know how to work this out. 4 to the power of n equals 8, and we put them both to the same base. So 2 squared to the power of n equals 2 cubed. Cross cancel the 2's of the bases, and do the squared times n, so we have 2n equals 3, meaning n would equal 1.5. Now, with our final question, given that 4 to the power of negative n equals 32, find the value of n. So 4 to the power of negative n equals 32. Put 4 and 32 to the same base, so 2 squared bracket negative n equals 2 to the power of 5. Cross cancel our bases of 2's and times negative n with the 2, so negative 2n equals 5, meaning n would equal negative 2.5. And that, ladies and gentlemen, is the end of the day's lesson. I did say it was that easy. Thank you very much for watching. Please like and subscribe if you haven't already, and I will see you in the next one.